Welcome to my follow-on video of my soundproof room. This project was mostly focused on closing off the open floor plan of this dining room so that it could be my office and music room. My goal was to soundproof it enough to be able to play music without it being heard in the sleeping areas of the home, and add lots of natural wood to create the feel of a study or studio. The project consisted of making a set of double doors that were over 3 inches thick, built into a pair of isolated walls, and then a single door on another wall to close off the kitchen's butler's pantry. This is the original room. For initial rough layouts, I start in 2D with Visio. I was incredibly space constrained. My grand piano was the biggest challenge to work around, and I wanted room for a keyboard and organ, as well as room for a desk with 3 workstations to support my different jobs. Ideally, all this would be within a swivel chair arm reach of each other. I decided that was probably impossible and decided to procrastinate and work on the 3D model for SketchUp. I knew that I needed to frame out 2 isolated walls, and I wanted the front of the doors to line up with the transition tile in our existing floor. I wanted the doors to be able to fully open but also stay clear of the hallway, as this is our main entryway. To do this, I decided to make some shallow shelving that would allow room for the door handles to recess into the shelf. Both for aesthetics and further soundproofing, I planned to add wainscoting along the outside as well. This means I needed to take in consideration the reduced opening width with the wainscoting installed. Here you can see how the doors inset into the wall when open. This also helps create the column effect from the wainscoting that goes around the opening. With my design about 80% complete, it was time to start on the actual work. First, I made sure there would be no surprises in my archway. Then I took advantage of my walls being open and ran some Cat 6 and OM3 fiber to get high-speed data both to the office and later my kitchen. Natalie got to terminate her first Cat 6 cable. Then we drove all the way down to Vacaville, which is apparently the only place with Rockwell insulation in stock. I rented an insulation blower from Home Depot and made a ramp to get it out of my car. I was able to fill all the 14-inch cavities in my ceiling joists. Then I used a hole saw to cut 2-inch holes in between each stud so that I could fill the cavity. On my last stud wall, I couldn't figure out why it wasn't filling up until I realized my mistake. Next, it was time to frame the opening. I got these hefty 1/2-inch concrete anchors to go into my slab. I added 3/4-inch walnut ply to the back of the bookshelf. Not only did this help square the framing up, but added a lot of strength to that stud that would be there with the heavy door. I routed a groove on the bottom of each shelf to get indirect lighting. I used 24-volt strip lights along with a 100-watt driver and power that I brought in. I used the Glodopto Zigbee smart controller, which my Hue ecosystem recognizes, and that gives me integration with SmartThings as well as Google. The lighting gets hid in the bottom shelf, which will be removable so that I can service it. I also put in a 1-inch conduit in the event that I need to run future wires like a charge station. The shelves aren't very deep, but they're enough for some picture frames and displaying other knickknacks. Now I had to commit to a final design for my door. I really struggled with a lot of different options. The final design was a layered composition of walnut, mass-loaded vinyl, plywood, mass-loaded vinyl, an air gap, then plywood, mass-loaded vinyl, and walnut. I built a spreadsheet to calculate the weight of the door and then found hinges that would be capable of supporting a door that weighed nearly 180 pounds. These Simon's Work Tectus 3D hinges were incredible. They're adjustable in 3 dimensions. They're a concealed hinge, which means no hardware will be visible when the door is closed. And they had 3D models, which made putting it into SketchUp really easy. The router jig for this is about $500, but I found a Templaco jig that worked great for only $50. I started with the door jambs, marking the depth with a marking gauge at 4 mm, and then used tape to make the line more visible. Then I tapped in the pins and clamped everything up. I stole a 4-inch line from my chop saw dust collection to help keep down the mess. These hinges have 2 depths that need to be routed. First, I thought I would do this visually, since messing with the template thickness and the depth of the cut tends to get complicated, but that proved to be more trouble than it was worth. So I took a different approach the second time around. I clamped everything up. This time I had to add support for the front of the template so that the router weight wouldn't make it bend, and then tap, 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 get those pins set so I can restore the template to that position if I need to. And then, how about we just take the depth of the drawing here, add the template thickness, and then use a depth gauge to set our router bit depth. What an idea. So we don our ear protection and eye protection, make sure everything is set, switch on our dust collector, and off we go routing. I'm using the steps on my router to incrementally approach the ultimate depth. Then to route the deeper section, I remove the red tabs and adjust my depth gauge again, and away we go. This part scares me a little bit because it is so deep that the bit is barely long enough and I have to have it out of the collet a lot further than makes me comfortable. And time for a fit test. Then it was time to bring the jambs in, install them into the rough opening, and make sure that everything was nice, square, and plumb. I like to check things out as I go, so I also routed out the style of the door hinges and fit them in too to make sure that everything wound up coming together. And what do you know? It did. This was an expensive set of 8-quarter walnut that I really didn't want to mess up, and I am so glad I didn't. Speaking of mistakes, I learned how to not transport drywall home. Let's talk about green glue. It's a viscoelastic dampening compound. You put it between 2 pieces of drywall. In a staggered stud wall, that gives you about 9 STC increase. So we're sandwiching that green glue between 2 layers of 5/8 drywall, which is going to go up against that 3/4 ply bookshelf backing. I have to put this in now because I won't be able to access it when I frame that second stud wall. Next, I laid out all of my pieces, trying to figure out where the grain would look the best. I rough cut everything to length. Then I routed the tongue and groove for the frame and panel. I put a sacrificial piece behind my stock to prevent tear out. Then I did a quick dry fit to make sure that everything was going to work out properly. I used my track saw to cut down the 3/4 ply. I try to design dimensions so that I can get the most out of a single sheet. I used my table saw to cut a 1-inch deep groove that the 3/4 inch ply will join into. I have a saw stop, so I'm pretty lazy, don't want to mess with the dado stack, so I just do a whole bunch of passes on a single blade and then hog out the rest with a chisel. And another dry fit, this time with the ply inside. Now I just have to make a panel. With every good project comes the purchase of a new tool, and my wife is wonderfully supportive of me. I'm getting pretty good at building ramps and getting heavy things out of my car alone. I wasn't actually planning on purchasing a bandsaw for this project, but once I got into it, I realized I really needed one. This made quick work of a 12-inch wide 8-quarter walnut that I sliced into 5 nice veneers that were just over a 1/4 inch thick. Shout out to the Wood Whisperer and Alex for the video they posted on how to tune up a bandsaw. It made the world of a difference, and I'm not a bandsaw expert, so the instruction really helped me get going quickly. Then I ran the veneers through my planer, didn't have to take off that much thanks to the bandsaw tune-up. Then I laid the veneers out to get the right grain layout and book matching. Joining the veneers together proved much more difficult than I expected. I don't have a jointer, and for a moment I worried I might actually have to purchase a second tool. Ultimately, I was able to get an 8-foot level and used a flush trim router bit to clean the edges up. Then I applied tape to the joint, flipped it over, opened it up, filled it with glue, cleaned my glue up, then apparently cleaned up the glue even more. Threw on some clamping cauls, clamped them down, and then clamped the whole thing together. Then it was another quick dry fit. The advantage of this being backed by ply is that I can actually drive screws in to hold it all together, which means I can take the front half of my doors, which weigh significantly less than an entirely assembled door, into the house, hang it in the rough opening, make sure all my dimensions are perfect, and then build the rest of the door to those dimensions, knowing that I'm going to get an exact fit. Another huge shout out to Wood Whisperer and Bourbon Moth for introducing me to Rubio Monocoat. This stuff is awesome. I tried a whole bunch of color samples and realized pure is the only way to go for walnut. I used a random orbital to 180 grit and then came back with a finish sander and finally hand sanded to 120. I used mineral spirits to clean it, let it dry overnight, and the next day used a spreader to apply the monocoat and then rubbed it in with a Scotch-Brite pad. I can't tell you how happy Rubio Monocoat makes me compared to the other finishes I've had to do. After everything's rubbed in, I come back with a shop cloth and wipe all of the excess off. Here's a side-by-side of the unfinished walnut next to the pure finished Rubio Monocoat. Next, we come to one of the exciting parts of how to soundproof a door, the automatic door bottom. This is a mortised version that goes in the bottom of the door. Because the door was layered, I was able to design it so I didn't have to route much material out, but I still had a bit that I had to take out of that 8-quarter walnut. I just clamped up some wood, used my hand router, and then cleaned it up with a chisel. To cover the ply on the edges of the door, I cut another piece of walnut, and then put a groove in it along with this loose tenon, which will get sandwiched in between the 2 layers of ply and create the air gap through the rest of the door. Now, I don't know if there's a benefit or not to using green glue between the mass-loaded vinyl and plywood, but the least it can do is help secure the mass-loaded vinyl. Now this will sit right below that 1/4-inch walnut veneer and act as a support for the panel. I used staples as well to help secure it. This is a good view of the layers in the door. Here on the right I've got a block screwed in to support that thin veneer for where the door bottom's going to go. Here you can make out the air gap separating the 2 sheets of plywood in the door. Then you can see how the plywood is sandwiched between 2 layers of mass-loaded vinyl. Now it was finally time to finish the assembly of the frame and panel of the front side of my door. Just kidding. Before putting it all together, I did a quick sanding job on the inside edges while they were more accessible. Then I made the split decision to put finish on these inside edges. Okay, now I'm putting it together. This is really just like an oversized cabinet door glue up, except I was a little worried about the long panel being challenging to get into the groove. Having that mass-loaded vinyl below the panel actually worked out really well for lining it up. Like usual, I wiped up my excess glue and then started clamping everything together. Before I could work on the backs, I had to figure out how the doors were going to come together. I didn't want a hardware astragal, and I didn't want to have a traditional latch that would put a big hole all the way through the door. That meant that I had to figure out how they would close and stay closed, as well as seal. I decided I would try to use magnets concealed by the gaskets to hold the doors shut. I didn't know how many magnets it would take to keep the doors closed, but I knew that I could add them once the doors were hung. I also left a kerf in the stile so that a gasket could be inserted or removed. Then I chiseled out the space for the flush bolt. Having a layered door made it much easier to run the latch all the way up to the bolt through the door. Natalie signed the work for us. Then it was covered in green glue and another layer of mass-loaded vinyl stapled on. I always dry fit my pieces, and in this project I had done it so many times I cut a corner right before the glue up here. I forgot that the rears of the doors were different dimensions and had the panel for the opposite door here. The panels have a sound dampening foam on their border where they meet the frame. So this is me frantically trying to figure out where I left that foam, and then haphazardly trying to apply it before all my glue dried. It's a good thing we're not playing the original audio. But I was able to get the right panel into the frame. It only took a little extra glue and a lot of extra hitting it with a mallet and some creative use of clamps to get it all squared up. That's how to not do a glue up. Anyways, here's the whole door clamped up. You can see how thick it is. Then it was time to ease the edges, sand it all down, and start the finish. We talked about the Rubio monocoat before. We can talk a bit more now. It's basically a 2-part mix. I use my kitchen scale, well, my wife's, and then I clean it before she realizes it's missing. Mix everything up, and then basically just use a scraper, and a little bit goes a long way. You can see it's just a slight dribble on there, and with this scraper, that little bit covers the entire door there. Come back around with a Scotch-Brite pad and rub it all in. On the vertical surface, I just used a foam brush. A regular brush probably would have been a little bit nicer. And then since this was I was doing a whole bunch of finish work at once, I used a Festool Rotex with the polishing attachment on there with one of the garnet pads. And that just made it a lot easier to get everything rubbed in real quick. Then you just come back around with a rag, paper towel, shop towel, and wipe off the excess until that towel comes back clean. Here's just a close-up of how the doors come together in the channel that's going to hold those magnets. Alright, now my favorite part, the automatic door bottom. We drilled a hole in that side veneer, and that allows a pin to come out that when pushed, engages the door bottom. The pin pushes into the door jamb as the door closes. Here you can see the pin start to press into the door as the door closes, and then the seal begins to lower, blocking the light from the room. As we open the door, the seal retracts and the light starts to shine through, and again closed. Knowing it would be challenging to hang a very heavy door, I deliberately planned the gap under the door to line up with furniture movers that allowed me to slide the door into place, so with the help of my neighbor, the installation actually wasn't too bad. After I got the doors hung, I was able to use my bandsaw again to cut veneer for all of the shelving. I added trim, did a light sanding, and then applied my finish. I'll say that this project made me very thankful for my dust collector. We're going to jump back in time now that the doors are finished and look at that second stud wall that's isolated from the first wall. You can see the 5/8 drywall that we put behind it, and then this 2x3 frame now that we've constructed with a gap in between. It's mounted separately into the slab, and then we filled it with insulation and then covered it up with drywall. That light switch gets moved closer to the door later too. We're going to take a little bit closer look at the layers. First, you might notice that there's a foam backer rod that I stuffed in there to try to seal everything up. We've got the 3/4 inch ply that's at the back of the bookshelf, and then we've got a drywall green glue sandwich with 5/8. Then we've got our air gap going into our second stud wall that's filled with insulation, and then another layer of 5/8 drywall green glue sandwich. After I installed the Jamb extensions, I wanted to show how easy it is to touch up Rubio monocoat. These were already finished in the garage, and when I brought them in, I used my nail gun and then filled those holes with putty. 5 to 10 minutes of sanding in Rubio monocoat, and you'd never know they were there. I applied green glue and a second layer of drywall to the entire wall. I did all the tape and mud and even patched all of those 2-inch holes that I used for the blown-in insulation. Then it was time to texture. I got a large pre-mixed bucket from Home Depot for about $20, a cheap gun from Amazon for about $30, and used my existing compressor. This was my first time doing drywall and texture. I was a little intimidated by the whole project, but I was pleasantly surprised with the outcome. And I was able to move quick at the ceiling joints because I knew I would be doing crown later. Then I closed up all of the gaps with a green glue noise-proofing sealant, which is essentially an acoustic caulk, and then added the trim. There are a few places where I needed to meet up with the original baseboard in the house, and in those cases I had to cut some very small pieces. To do this, I made a zero clearance tiny part hold-down jig that goes on my chop saw. You can see that I was able to make some really nice thin cuts to fit into some tricky spots. So that's most of the highlights of the build. Show a few things here. I talked about how I hid the electrical down there. Here is how you can open the compartment to service that. Here's a view of the finished product before the wainscoting from the front. And with the door open, you can really see the thickness of the door. Because of that door weight, I wanted to have some really solid handles that felt good when you're opening these doors. These are 1 foot long oil rub bronze through bolt mounted pulls from Rockwood. I got almost all of my hardware and gaskets from Trademark Hardware. Their website's great, and those Simon Works Tectus 3D hinges are just incredible. The ability to adjust in all 3 dimensions proved invaluable as I was dialing these doors in to have a minimal reveal. The hinge motion is so smooth, opening these heavy doors is almost effortless. And for these all walnut doors, it's awesome to have a concealed hinge aesthetic. But now we have to approach our moment of truth. Does this room actually live up to the soundproofing that I was going for? Now I know I haven't done anything to the other walls or the ceiling or the ducting, but I wanted to see if this would be good enough. If it's not, I can always do those other things later. So what we're going to do is just use this tablet here to visually show you the needle moving. This needle's not calibrated in any way, so we've got a microphone set up instead. This is a really nice AKG C14, and these monitor speakers, we're going to play a swept sine wave here. This is what the waveform looks like. We're going to do this test with the door open and then with the door shut. I've put the phone mic in the left track and the studio mic on the right track and lowered both by -12 dB so you don't have to hear a loud sine wave. And now a test with the door shut. All right, what we're looking at here is just my digital video audio workstation software. The left waveform half is the door open and the right half is the door closed. The top yellow ones are off of my phone's microphone, which is going to have some automatic gain control probably, so you can't use it as a reference. And the bottom green waveforms are from the studio microphone. All right, here is a side-by-side spectral comparison. The left half is the door open and the right half is the door closed. You can definitely see a significant drop in intensity. Right? That red line on the left is that really loud swept sine wave, and on the right, significantly reduced. If we zoom in a little bit, 500 hertz to 4 kilohertz, you can see my microphone wasn't actually ideally set up. I'm essentially clipping at 0 dB for the door open case. But for the door closed case, we're down peaking around -35 dB with the majority of that yellow around negative 50 dB. That means we're getting about 25 to 30 dB reduction. I'll conclude this video by saying I'm a complete amateur. I've just started doing these types of projects for myself. I appreciate any sort of constructive comments people want to give me, point out things I've did wrong, things that I can do better. And I'd like to give a sincere thank you to those that post on YouTube that teach people like me how to do these things. Wood Whisperer and Bourbon Moth, the content that you put out there has allowed me to learn so much in so little time that I'm able to take on projects like this with almost no experience and be successful. Thank you for what you do, and for those that have watched, if you're interested in woodworking, check their channels out.